Okay. Good. So here is a combo. This is function 1. This is function 2. This is a product. But in addition to the product rule, we have to apply the quotient rule because it's a function to a power, another function to another power. So remember what we're going to do. Y prime, 1 prime times 2 plus 1 times 2 prime. So y prime equals this function prime. Can anyone help us with this? Bring 7 down, subtract 1 from the power, times the inner function prime. What is the inner function prime?
1.
That's it. So now I have to copy 4x minus 1 to the 10th power, plus. I copy the first one. And now can anyone help us differentiate the second function?
Times the quantity 4x minus 1 times 4.
10 times 4x minus 1 to the
9th power.
Very good. Times the inner function prime, which is 4. Awesome. Now this I want to continue simplifying by factoring. This is important. Okay. So this is one term, and this is the other term. Can anyone identify common factors and tell me what to pull out from these two terms? This term plus this term. What can I pull out?
X plus 5 to the 6th.
Very good. X plus 5 indeed to the 6th power because it's the smallest of these two. Awesome. Great job.
And also 4x minus 1 to the 9th.
Yes, because it's the smallest of these two. And then open brackets. So carefully, let's see what is left from this term. Obviously 7 is left in. From these 6, I removed all of them. So this is gone. But from these 10, I only took in front 9 of those. So 1 must be left inside. How do I know? Because when I multiply this by this, I will recover this term. 7, 4x minus 1 to the 10th, and x plus 5 to the 6th. Now plus. Let's see what is left from the second term. Obviously the 4 and 10, which is 40. 4x minus 1 to the 9th is completely taken out. Gone. From this 7, I removed only 6 of those, so 1 must be left inside. I will combine like terms here. These will not change, but I will combine like terms and simplify this, and it's done. So x plus 5 to the 6th, 4x minus 1 to the 9th. Here I have 28x and 40x, 68x. Negative 7 plus 200, I think, plus 200, right? Yes, that's correct, negative 7 and then 200, yes. So I write it one more time. 4x minus 1 to the 9th, and 68x minus, I think it's plus 193. 200 minus 7. And this is completely and fully simplified. Very good pick. Thank you. Thank you for picking this problem. Any questions? Anyone? Any questions? Okay, let's go back. Let's see what else we would like to look at. Any other? If you want me to go back, we can go back to the previous page. Anything you'd like to look at? There's so many.
Can we do number 40?
Yes. Let's take a look. Number 40, right here. Okay. Good pick. 40, it's f of x equals the cube root of 4 minus x to the third, x minus x squared. This is not a simple situation. It's not a trivial situation. And of course, I'm not going to deal with this like this. I'm going to have to change it into which power?
1/3.
Very good, awesome. 1/3. So the cube root is power 1/3. The square root is power 1/2. So, and so on and so forth. So this is indeed 1 divided by 3. Okay, let's start. We bring down the power. We subtract 1 from the power. 1/3 minus 1. 1/3 minus 1, we should know that this is negative 2/3. If you need me to show this, please say so. Times the inner function prime. So I differentiated the outer. I brought the power in front. I subtracted 1 from the power, according to the rule here. Let me write it one more time so it's here handy. So f to n power prime is n times f to n minus 1 times f prime. I have it written 2 pages ago. So we brought the power in front. We subtracted 1 from the power of this function. But now we have to differentiate, but this is a ratio. I have to use the quotient rule. The denominator has to be squared. But now the numerator. Can anyone give us the derivative of this numerator?
Negative 3x squared.
Negative 3x squared multiplied by the denominator. That's the rule, minus the numerator multiplied by the denominator prime. Can anyone other than Nick give us this derivative? Denominator. So I can put it here. And I'm going to, because I don't want to squeeze it in so you cannot see it, I'm going to put it up here, but it should be here.
Negative 2x.
But what about x prime? 1. The slope of x. That's what it is, 1, right? So 1 minus 2x. Is that clear, everyone? Please do not get tempted to simplify this with this. That would be a terrible mistake. This is not a factor at the top. So again, this is not, I'm glad you picked this problem, but it's not a trivial problem at all. Okay, 1/3. Then I have 4 minus x cubed over x minus x squared to negative 2/3. I copy the denominator. And now let's see what I can do here. Negative 3x squared times x, negative 3x cubed, negative 3x squared times negative x squared, positive 3x to the fourth. 1 times 4 with minus in front. 1 times negative x cubed with minus in front. Negative 2x times 4 with minus in front. Negative 2x times x, negative x cubed. So this is positive 2x to the fourth minus 2x to the fourth. Okay, so the only thing I can do is just combine these two. And I didn't mean that. Combine these two. And then combine these two. So then I have 1/3, 4 minus x cubed over x minus x squared to negative 2/3. And I start with this. So this is x to the fourth. Then I have minus 2x cubed plus 8x and minus 4. This was again an interesting problem, but a little bit of a torture because of the way it was set up with the cube root of a ratio. but that's okay. We had to see at least one. Any
Can we
question?
do number 36?
Yes, let's take a look at 36. 36. What does 36 say? Okay, that's it. Yes, that's a nice problem. Quite nice. So 36. So f of x, 7x to the fourth plus 6x cubed minus x to power 204. I'm going to stop sharing. That's here. There is no problem. Just put the power in front. Subtract 1 from the power and differentiate this. Times, I don't have enough room, so times, right? Bring down 4, 28, x cubed, bring down 3, plus 18, x squared, and the derivative of negative x is negative 1. So this should be right here, continuing. Very good. Okay, so let's take a look. Let's look at some word problems now to see how we apply all this. Let's see what is interesting here. Well, compound interest is interesting if you would like to. Consumer credit. Okay. Consumer credit is interesting. Chemotherapy is not, but necessary in some cases. Okay. So we have plenty to choose from. Do you want to start with compound interest? Okay, so let's continue with compound interest, number 77. Okay, we're given the formula, which is A of R, 1,000, 1 plus R over 4, everything to power 20. It says 1,000 is invested at the rate R, compounded quarterly, so that's quarterly, that's number 4 here in the denominator. We had this formula before when we reviewed. In 5 years, 5 times 4 is 20 right here. It will grow to an amount, yes, section R, that one, we know that. Good. Then find the rate of change dA over dr. So let's stop for a second. So remember, we have two notations. A prime of r is the same with the derivative of a with respect to r, differentiated with respect to r. The derivative of a differentiated with respect to r. So the same thing. The constant stays in front. There is no problem there. We bring 20 and multiply. So we have 20,000. And 1 plus r over 4, subtract 1 from the power, times the inner function prime. Remember, the inner function can be written like this. It's a linear function. So the derivative of this is just its slope because it's linear. What will be the slope of this line?
One-fourth.
Thank you very much. Awesome. So I'll simplify. And I have 5,000 here. So I will continue with 5,000. And in parentheses, 1 plus r over 4 to power 19. So this is the derivative of this function, either a prime of r or the Leibniz notation dA over dr. Now there is, I think, part B there. Interpret the meaning of dA over dr. So the interpretation for dA over dr is the rate of change of amount with respect to the annual interest rate. That's what it means. Okay, so let's choose another word problem. And then I just would like to show you the last section of this chapter is just other derivatives, second derivative, third derivative. Nothing new, really. Okay, so what would you like to look at? We want to look at consumer credit.
75.
75, consumer credit. Okay, let's copy it.